the presentation. So let's get to the presentation. So hello everyone, my name is Aryan. I am 13 years old. I am studying in 8th grade, and today our topic would be about the Big Bang. Introduction to the universe. So the universe has fascinated humans for thousands of years, inspiring myths and scientific inquiry. Understanding its origin has been a central quest in astronomy and physics. Modern science now offers a compelling explanation, the Big Bang Theory. Early human observations of the sky. Ancient civilizations observed stars, planets, and celestial events to understand the cosmos. These observations laid the groundwork for early astronomy and calendars. Despite limited tools, early people speculated about the universe's origin. In the so early humans observed the sky and made patterns out of them. They also observed that if you go somewhere far down, the positions of the stars will change a little bit. The geocentric model. For centuries, humans believed that the Earth was the center of the universe. Ptolemy's model placed Earth at the universe's core, influencing astronomy for a millennium. This view was challenged by new observations in the 16th and 17th centuries. So at that time, what used to be the case is that if you try to go against the church, so church held the power at that time, you were accused of heresy, and you would be called out to the court, and you have to admit that you were publicly wrong. So Galileo also had the same faith when he challenged the geocentric model. So the geocentric model is that people believed that the earth was the center of the universe, and this was challenged by many people like Galileo, Copernicus, and many more.
Biotanic Bruno also.
Yes, the Copernican revolution. So Nicholas Copernicus proposed that the sun, not Earth, was the center of the solar system. This heliocentric model revolutionized astronomy and challenged previous cosmological ideas. It set the stage for modern understandings of the universe's structure. So the Copernicus revolution came. So now what happened that Earth was believed to be at the center of the solar system. So in the geocentric model, what used to be the case that Earth was in the middle, the the moon, other planets, and the sun revolved around it, and above that it was the heavens. So, but there were many flaws to it, like it could not explain eclipses, and people also believe at that time that the earth can is round, and so there were many things it could not explain the Mars revolution or orbit. So like Mars orbit was relative to us, so it meant that when we observed it, it showed retrograde motion. So it meant it traveled back in our perspective, and that happened because it's moving relative to us. So people could not explain that with the geocentric model. And then uh, I think so Tycho Brahe's assistant Kepler, he tried to fit these orbits into circles, but he could not. But then he tried eclipses, but that worked wonderfully well. So that is why we have eclipses has orbits. Galileo's and telescopic discoveries. So Galileo Galilei used the telescope to observe moons around Jupiter and phases of Venus. These discoveries provided evidence that not everything revolves around Earth. They contributed to the shift towards an expanding universe. So, does anyone here know how does an Galilean telescope work? Hello, Saksham, do you know how does an Galilean telescope work? No, okay. So, Satyajit, do you know about it? How does an Galilean telescope work?
Yeah, so it has a convex lens and a concave lens. So using those two lenses, it somehow works.
Is it taught in schools?
Not yet, actually. We
Okay.
haven't.
The discovery of the Milky Way and the nebulae. Early astronomers identified the Milky Way has a band of stars in the night sky. Observations of nebulae suggested the universe contained many distant, separate galaxies. This expanded the scale of the universe dramatically. The concept of an expanding universe. In the early 20th century, astronomers observed that galaxies appeared to be moving away from us. This suggested that the universe itself is expanding over time. The idea of an expanding universe was critical for developing the Big Bang theory. So, I have a question for everyone. The concept of an expanding universe. Why did it come in the 20th century? Like why it couldn't have come early in the 19th or the 18th century? Because around that time we knew uh, what I think someone was trying to say something. Right? Okay. So why did this concept arise in the early 20th century? Why not earlier? So
Can you please repeat your question clearly?
so why did this concept of an expanding universe come in the early 20th century? Why not earlier?
That's because in in the 19th or in 18th century, people believed that the Earth is the center of the universe, and every object in the universe, like sun, milk, and all the stars orbit it.
Okay. So, Gaurav, I think so. You were also trying to say something.
Yes, it may be because they didn't have any powerful telescopes to see the distant galaxies.
Okay. So, Satyajit, what do you want to say on this?
I would generally assume it was because of the mathematical shift, like be that the general relativity or whatever, it came in those time period. As you mentioned, early 20th century. So that would be my assumption.
Okay. So, it was let me tell you, it was mostly because of the mindset of the people living in the centuries. So like uh, even Newton, Isaac Newton believed that the universe is infinite and static. So then one question arises that if the universe is static and infinite, there are stars, and if they are non-uniformly distributed, it would lead to contraction. And Newton had many problems trying to solve that question. So there were people that believed that the universe could be expanding or contracting, and there were people who challenged this infinite static universe. And one more, and okay, so uh, this infinite thing has been also challenged before. It has been challenged by the Obler's paradox. I think so. It was a question given to Newton. If the universe is infinite and static, there should be stars at each line of sight. So it means that everywhere we look, there should be stars. And if the universe is infinite, the light rays coming from them would make the sky glow, but that's not the case, it's black. And one more thing, that if there's gases in between, what would happen, they would also shine brighter and brighter. So we do not see that effect. So it means that the universe is not infinite. So like by uh, these questions, people came to an conclusion that the universe is not uh, has not been there for infinite. So like people always tend to go with this eternal stuff to comfort them, and I think so. This was also written in the book behind me, brief answers to big questions. So uh, did everyone get me, or are there any questions to it? Okay, Satyajit, you have any question?
How does the scale of universe, be that infinite or not, have to do anything with contraction or expansion?
Okay, so if the universe was infinite and static, there would have been a star at every place we see in the sky. Uh, let it be north or south. There would be an star in every place. So if we look into the sky, they should have been, like, even if light traveled at infinite speed. I don't. Let's not get to that. Uh, if the universe was infinite, the light would have reached us, and the gases that interacted in between would have gotten also heated. At during that point of time, they should have realized that how they figured it out.
Because expansion and contraction of the universe. So you said if it was infinite, then it ought to expand either or contract. So that
Okay,
doesn't make sense.
okay, I think so. I misunderstood your question. So if the universe was infinite and static, there should be stars in every place, and if even if there's a slight disturbance, like we are assuming that the stars are uniformly distributed, even so that would mean that one star is pulling on other, and it would mean that the universe should contract. So but it's not happening. So this also replaces the static universe conclusion. So did I answer it?
So there is no scope of expansion in an infinite universe, but contraction is mandatory.
Yes.
But they would be contracting for
Sorry, repeat yourself.
So in that case that you just mentioned, what is the universe contracting into? I mean, there is not a single point to be called as center. So what is this all contraction being at?
Okay. So
Would that be totally random?
uh, in an infinite universe, each point is considered to be its center.
Yeah.
So I think so.
So the
It's
contraction would be random.
yeah, but
When you talk about contraction, you assume that there is a center. So if there is an infinite universe and every point can be called as the center, then where is all these contractions going to happen in that case?
okay, it will be chaotic, but whenever that in which if that happens on any point, it would be considered a center, because in an infinite universe, it would every point is in center of the universe. So okay,
So eventually we'll be seeing some masses contracting here and some masses
yes,
there. So that is what's happening there.
yes, it would be chaotic. So do you have any other further questions?
So that is not a uniform
Yes,
universe anymore.
yes.
Okay.
Okay, so Gaurav and Saksham, do you have any questions? Okay.
But I have a question that
Okay.
why maybe the color of the sky will be blue if the universe is infinite?
Okay. I think so. You heard it wrong. So I was saying, if the universe was infinite, the sky would be glowing. The night sky would be just glowing, but we only see few stars, and that is the case because the universe is not infinite. Uh, like, even if the universe was infinite, why should the sky be glowing? It should be glowing because the light reaches us in an infinite universe. It should reach us, and if has been there for an infinite time, and the gases in between that come and interact with those photons should also heat up, which means that we'll see an glowing sky. So, did you get why should the sky be glowing if the universe was infinite?
But why would be the gas molecules will be heated?
Okay, why should the molecules be heated? Because they are absorbing light. They are absorbing the photons, the radiation that comes of stars. Did you get it?
Yeah.
Okay. So, Saksham, uh, can you read this slide? Edwin Hubble's observations.
Okay, Aryan. Edwin Hubble's observations. Hubble discovered the relationship between galaxy distance and their speed of precession. This relationship is now known as Hubble's law. His work provided strong evidence for an expanding universe.
Okay. So, Saksham, this is just one of the observations that concluded to the Big Bang theory. So, do you know about what was the other observation? How did we know that the Big Bang happened?
I know, Aryan, about the Hubble law, in which, according to Edwin Hubble, the galaxies which we see billions of light years away are receding much faster than the nearer galaxies.
Okay. So, there was one more, there were few more observations. So, there were two people who designed a very sensitive microwave detector. Lambda CDM of the universe. Okay, we'll get to that later. So, there were two people who designed a very sensitive microwave detector at night. What happened? They were getting a constant hiss sound, like they were getting a constant hiss at night. So, they checked for bird droppings on there and many other factors. And the only thing that they concluded is that it was the radiation left after the Big Bang, which we now know as the cosmic microwave background radiation. Some new people have also joined, so thank you for joining us. If you have any questions, you can raise your hand and ask us. So, Edwin Hubble's observations. So, Hubble discovered a relation between galaxies' distance and their speed of recession. This relationship is now known as Hubble's law. His work provided strong evidence for an expanding universe. So, even Einstein was a part of that mindset that the universe should not contract or expand. So when he was doing the maths, he realized that the universe is expanding. So then he added uh, an and some other variables known as the lambda to cut out these expansions. So it was later known as Einstein's biggest blunder, the steady state versus the Big Bang debate. For decades, scientists debated whether the universe had a beginning or was eternal. The steady state proposed a universe that looked the same at all times. The Big Bang theory gained prominence due to observational evidence. Obler's paradox. So Obler's paradox asks why the night sky is so bright night sky is dark. If the universe were infinite and filled with endless stars, every line of sight would eventually hit a star, making the entire night sky completely bright. The darkness proves our universe has a finite age and is constantly expanding. So this was the question that was asked to Newton. He couldn't answer. I can't remember his answer. But this is the paradox which asked why the night sky is dark and concluded that the universe should have a finite age and is constantly expanding. Discovery of my cosmic microwave background radiations. In 1965, Arno Penzias and Robert Williamson detected a faint microwave radiation permeating the universe. This was the residual heat from the early universe, the CMD strong evidence supporting the Big Bang model. So, as I said, these two people had invented a very sensitive microwave detector, and at night they had a constant his from that detector. They checked for many things, and then concluded that it was the microwave background radiation. I think so. They also got a Nobel Prize for this. The Big Bang Theory explained. The Big Bang described the universe's originating from an extremely hot and dense state. It has been expanding and cooling over approximately 13.8 billion years. This model explains the distributions of galaxies and cosmic microwave background radiation. Evidence from galaxy distributions. Observing Observations show galaxies are spread uniformly, but with some clustering. This distribution is consistent with the universe's expansion from a hot, dense origin. It helps scientists understand the large scale structure of the universe. So, someone has raised a question: what are quantum fluctuations that happen during the Big Bang? So, people suggest that the Big Bang happened due to quantum fluctuations, and I read in I think so this book that you can get a universe for free, and he was Stephen Hawking was just talking about the Big Bang, and and there were questions about what happened before the Big Bang, and he said it's like asking a question, what is south to south? So no time existed before that, and he suggested that quantum fluctuations created the Big Bang. And a line that I remember from that is that you can get a whole universe for free. So, any questions, anyone? Hello, Saksham and Satyajit. Do you have any questions? Okay,
Go ahead.
okay.
I had a question that what is LADB, like that something you have mentioned
A microwave
before.
background radiation, CMB. Are you talking about CMB, right?
No, lambda, like that
Okay.
anything.
So Einstein was like doing the maths of the universe, and he found out that the universe was expanding. So then he added an variable called lambda to cancel this out and make the universe not expand or contract. So then it's now later known as the biggest blunder of Einstein. So did you get what is lambda now?
Not quite.
Okay. So let's say Einstein was just doing maths, And then after doing the math, what he found that the universe was expanding. So to cancel out this expansion, he added the lambda. He added an lambda. It's a variable to cancel out this expansion. So I think so. Did it explain it?
Yes, but how lambda can cancel out the expansion of the universe? What was in it?
Okay, so how how does lambda? Okay, I didn't get what you were saying. So can you repeat your
So
question?
the lambda causes the expansion of the universe, right? The constant value shows that there's dark energy in the universe, right?
Okay. So someone else answered a question. So are you satisfied?
It was not quite audible.
Yes, I also couldn't hear that. Uh, I think so. It's a name. It was due to dark energy. Yes, it's so dark energy and dark matter. So he concluded that the universe's expansion is getting cancelled out by this lambda, uh, known as dark matter. So it is matter that we cannot observe, and it's also helping the galaxies to be stable. So, like it's matter that we cannot observe and is helping our universe not expand. So that was Einstein's lambda, the cosmological constant. So did you get it, Gaurav?
Yeah, got
Okay.
it.
Nucleosynthesis in the early universe. The Big Bang theory predicts the formation of light elements like hydrogen and helium. These elements were created during the first few minutes after the Big Bang. Observations of elements abundance support the predictions. So right now we have mainly talked about three observations of the Big Bang. It's like the nucleosynthesis, and nucleosynthesis is the reason there why there are more lighter elements because of nucleosynthesis. The particles, the helium and hydrogen, these combine to form other elements like lithium, deuterium, etc. So the observation of lighter particles, the CMBs, and the expanding universe suggest that the universe had a beginning, and that beginning is now known as the Big Bang. The role of redshift in cosmology. Redshift occurs when light from receding objects shift to longer wavelengths. The degree of redshift indicates how fast galaxies are moving. Redshift measures are crucial for understanding the universe's expansion. So, when we look farther, the redshift gets more intense. So, the blue means it's approaching us, and the red means it's going far away from us. Modern cosmic observations, space telescopes like Hubble and Planck, have provided detailed images of the universe's early stages. These observations refine our understanding of the universe's origin. They continue to test and improve the Big Bang model. Inflation theory. To explain certain uniformities, scientists propose a brief period of rapid expansion called inflation. Inflation occurred fractions of a second after the Big Bang. It accounts for the large scale uniformity observed in the universe. So it means that our universe is expanding faster and faster. Introduction to the Big Bang. So the Big Bang theory explains the origin of the universe from a hot and dense state. It suggests the universe has been expanding since its inception. Understanding the Big Bang epochs helps us learn about the universe's earliest moments. So now we are going to, after these slides, we are going to talk about Big Bang epochs. So these are times shortly after the Big Bang. Overview of cosmic epochs. So Cosmic epochs are distinct periods marked by different physical processes. Each epoch provides insights into the evolution of the universe. Studying these epochs allows scientists to piece together cosmic history. The Planck epoch. So this is the earliest period and it happened immediately after the Big Bang. Lasted up to 10 raised to the power of minus 43 seconds. Physics as we know it breaks down and quantum gravity dominates. We have more direct observational evidence from this epoch. So, Section, you raised your hand.
Aryan, your voice is fluctuating.
Wait a minute. Let me just check my internet connection for a while.